Hi guys, welcome back. We are ready to start our lesson on section 1.3. And again, we're going to be dealing a little bit more with functions today, and a couple things I need you to have for the video. I'd like you to go ahead and make sure that your textbook is handy. We're going to be referring to some of the things in your textbook, and again, you're going to need your calculator. So just assume you're going to need your calculator every night. But for this one, I really need you to have that textbook handy too. And I apologize, that squeaking you hear in the background is my chair. I really need to get the WD-40 for it. So, we're going to start off today with, again, you have your vocabulary, talking about increasing, decreasing, constant, maximum, and minimum. So, an increasing function. The book has an awesome picture reference for this. So if you would turn, if you have your book handy, if you turn to section 1.3 and look on page, if I can find it, 158. Okay, and we can just real quick talk about these. Okay, and I apologize if there's a slight glare on my book. Remember that we read from left to right. So, from left to right, this function on this interval is increasing. Left to right, this one is decreasing. And left to right, this is staying constant. Okay? These open circles mean that at that point, the function doesn't exist there, it exists right next to it. If that had been darkened, it means the function exists there. Okay? And that comes real important when we start talking about domain and range. Alrighty? But let's start off with something called a piecewise function. Right? So example 1, we're going to evaluate a piecewise function. So let's say you have function c, and piecewise functions look weird. Alright, so you have function c, and depending on the value of t, depending on what that value is, decides whether you pick this or whether you pick this as your answer. Alrighty, so let's say that the first thing I ask you to do is find the value of c of 40. So you ask yourself, is 40 between 0 and 60, or is it greater than 60? Alright, so obviously 40 is right in the middle, so then my function would be 20. And that's it, that's my answer. So a piecewise function is almost like a fork in the road. You decide based on the value for the domain that you're putting in, which path you have to take. Alright, so let's just do one more of those. Let's say that we input in 80. Okay, so come up here and decide which path you're going to take. So our domain is 80 in this case. 80 is greater than, so I'm going to apply this function, this path. So I'm going to do 20 plus 0.40, 80 minus 60. And then I go ahead and just do the evaluation. So 20 plus times 20, so it's 20 plus 8, which is 28. Okay, so piecewise functions look much worse than they really are. They're not bad guys at all. Okay? Alright, so now let's talk about places where functions increase, decrease, or remain constant. And I'm going to have you go ahead and turn in your book to page 158. Okay? And that's what we'll be working at. Alright, so example 2. State the intervals where a function is increasing, decreasing, or constant. Where the function is increasing, decreasing, or constant. Alright, and the first thing we're going to look at is example 3 on page 158. Okay? So I'm going to take a minute, I'm going to put my textbook up here so you can see the function I'm talking about. I'm going to go ahead and try to zoom in so that I can really blow it up for you guys as best I can. Okay, so what I want you to be able to do is decide where is the function increasing, decreasing, and remaining constant. So let's start with increasing. Again, we're going to read from left all the way to right and decide at what point does it begin to increase. So here we start, we're decreasing, 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 decreasing. Right here, we're going to start to increase. And at this point, again, we're going to decrease. Now, these points where it changes direction are not where it is decreasing, not where it is increasing. So these are kind of like changes. It's almost like imagine you're at a roller coaster and you're at that top of, you know, like an Apollo's chariot, and you're there and you're hanging and you're not going up, you're not going down, you're just there. So that's what they are. So it's not increasing and it's not decreasing. So the way that you're going to be able to communicate that is whether you use a parenthesis or whether you use a bracket. Okay? So let me see if you can see what I write here. Right, so let's talk about increasing. So it is increasing from 0 until 2. But 0 and 2 are not increasing. So what I'm going to have you do is put a parenthesis. And the parenthesis tells me that 0 is not included. It's not where it is increasing. Okay? Then we're going to talk about where it decreases. So where does this function decrease? So it decreases over here. But remember, this function continues on and on and on and on and on and on. So the way you'll communicate to me is that from negative infinity until 0, it decreases. Again, 0 is a point where it's neither increasing or decreasing, so give me a parenthesis. Now, infinity is a concept, not an exact point. So I want you, anytime you use positive infinity or negative infinity, I would like you to put a parenthesis. Okay, that's the standard practice. And again, let's look back at our curve, and does it decrease anywhere else? Yeah, right here at -2, it begins the decline again. Sorry, at +2. And that 2 is neither increasing or decreasing, so I use my parentheses to infinity. Okay? Alright, does that help? Hope so. Now I want you to look at B. Right? And again, we're going to try to figure out where is it increasing, where is it decreasing, and if you notice, this one has a spot on the graph where it's constant. So this represents it being constant. Alright? So I want increasing, decreasing, constant. Alright, so let's start with increasing. So at what point in the domain do you feel that the function begins to increase? I'm hoping you said right here at 0. Now, do you see that that is an open dot at 0? So to communicate that to me, you'll use again a parenthesis and tell me that it begins to increase at 0 and it increases all the way to infinity. And what symbol do I put after infinity? You're going to put another parenthesis. Now, decreasing, is this function anywhere we go decreasing? No. so we're just going to put a line there. And constant. It's constant all along here, and again, that arrow means it continues all the way to negative infinity. So from negative infinity to 0, it remains constant. Now, that dark dot, the filled in dot, means that at 0, the function is indeed constant. So to communicate to me that that 0 is included, you'll put this bracket. That tells me that that the value when the function is 0 exists on the graph. Okay? Alright, now what I'd like you to do is look at, right below that, look at the graph on checkpoint 3. And I'm going to give you a minute again to try to decide if you think, where you think it is increasing, where you think it is decreasing, and when you think it is constant. So I'm going to give you just a few seconds and see what you can do. Alright, let's talk. So it looks to me that the function is increasing all the way up until this point at -1, and then it begins to shift and become a decreasing function. So I'm hoping that you wrote that it increases from negative infinity to -1. It decreases from -1 to 1. And again, it starts increasing from 1 to infinity, and it doesn't have a constant anywhere. So see if your answers look something like my answers. Again, really check these symbols, whether they're parentheses or the bracket. The brace certainly is something very different. Alright? Alright, next thing we're going to try to do today is to determine whether functions are odd, even, or neither. Okay? Alright, so whether a function is an odd function, an even function, or neither. Whoops, it would help if you could see. Let me unzoom a little bit. I think we're just super zoomed in since we were just doing. To determine if f of x is odd, even, or neither. Algebraically. Okay, there's two ways you can do this. You can do it algebraically or you can do it graphically. So let me go ahead and show you the algebraic method first. So step 1, find f of -x, just like you did yesterday. Step 2, if all the terms keep the same sign, in f of -x, then it is an even function. If all the terms take the opposite sign, then it's odd. If the signs don't all switch or all stay the same, it's neither. So if you get a mix of signs, let's just put that. Alrighty, so I think an example is going to help you quite a bit right here. So let's jump in. Example 3. So determine if each function is even, odd, or neither. Sorry, I just wanted to tweak the focusing. It just looks a little blurry on my screen. Alright, so step 1 said find f of negative x. So, just like yesterday, anywhere I have an x, I'm going to plug in, this time make a substitution of a negative x. And now I go ahead and simplify. So negative x quantity squared is x squared plus 6. Now you take a minute and you look at the signs in front of each term. So the x squared is positive here and positive here. The 6 is positive here and positive here. So my sign stayed the same, therefore this is an even function. Okay? Alright, let's try another one. Let's say I had g of x is equal to 7x cubed minus x. Alright, let's go ahead and find g of negative x. So I'm going to take out the x value and plug in negative x to each place. Okay? So negative x quantity cubed. So a negative x times a negative x times a negative x is a negative x cubed plus x. Now again, I want to look at my g of negative x and g of x and compare my signs. So a positive 7 became a negative 7, a negative x became a positive x. So both signs switched. So this is an odd function. Okay? Alright, I'm going to give you one more and let you practice it on your own, and then we can compare answers and see how you did. So last, let's look at h of x is defined as x to the 5th plus 1. And I want you to find, sorry, I'm dealing with function h to the negative x. So go ahead and simplify that, and then determine if it's even, odd, or neither. Alright, so let's take a quick minute and see how you guys did. When you finished up, you got that this was negative x to the 5th plus 1. And when you compared, the x to the 5th changed, however your 1 did not. So this is a neither. Okay, how'd you do? Wonderful. I do want to talk to you a little bit about symmetry, because I told you there were two ways you could do it. So one was algebraic, the other is graphically. Lots of people like graphically because they can visually see what the function is doing. Technically, I can ask it one way or another, so be prepared to justify it one or both ways. If it is an even function, is symmetric with respect to the y-axis. Okay, so this is an even function. Imagine that I folded on that point. I didn't draw a beautiful parabola. Let me see if I can sketch one that's a little better. There we go. Let's just ignore him for a minute. Okay, so here if you look, if you were to fold over, the two halves meet. Okay, then this is an even function. An odd function is symmetric about the origin. So an odd function is symmetric with respect to the origin. What that means is that if you were to take this and rotate it about the origin 180 degrees, do the two pieces match? So in this case, this is an odd function. And a neither function is just going to look weird. It's just not going to make any sense at all. It's not going to be symmetric about either. Okay? Alright, so that wraps up this lesson. Go ahead and hit stop, do your practice problems, and I will see you guys tomorrow in class. Talk to you later. Have a great night. Bye.